Today we're going to talk about the area of trapezoids. And I like to derive the area formula for a trapezoid. So it's going to involve each one of the bases. Remember, the bases are the two parallel sides of a trapezoid, and the height is a perpendicular segment from one base to the other. So we can actually break this up into two different triangles. We can have the orange triangle and the bluish kind of turquoise triangle. So the first one, the orange one, the area of that, I'm going to call that just that region area 1. Well, that one's easy to see. Area of a triangle is 1/2 base 1 times the height. Let's call the other area area 2. The area of that one, 1/2. This is the base, so base 2. The height is the perpendicular segment to that base. Even though it's outside, it's still considered the height. And these heights are congruent. Now to get the area of the whole trapezoid, we add those two together. So I get 1/2 base 1 times the height plus 1/2 base 2 times the height. What's in common? 1/2 and the height. So 1/2 the height, I factor that out. Base 1 plus base 2. So the formula for area of a trapezoid is 1/2 the height times the sum of the two bases. And again, remember the bases are the parallel sides. So our first example, they give us the height and the two bases. So it's just as easy as plugging into the formula, plugging and chugging. So area is 1/2 the height, which is 14, times 9 plus 17. That ends up being 182. I don't give us units, so you don't have to give me units squared. Next example, a little bit more complicated because we are not given, first of all, the height or the other base. So if I drop a perpendicular down, there, and there, we're going to have two congruent triangles on either side. We're going to have two triangles on either side. I guess we have to assume that this is isosceles. And then we also have two congruent triangles, and then we have a rectangle in between. So this whole length is 10. If I find the shorter leg of both those triangles, then we know that it's going to be, then we can subtract that from 10 to get that length. Okay, so the hypotenuse of our 30, 60, 90 triangle is 6. So therefore, the longer, or the shortest leg, the shorter leg is going to be 3, half the hypotenuse, and the height is going to be 3√3. So since those triangles are congruent, we couldn't do it if it wasn't isosceles, so I threw that in at the last minute, so we know it's isosceles. That's 3. This is 3√3. I should have had a 6 in there. So we know our area is 1/2. The height is 3√3. Base 1, well, I know one of the bases is 10. So let's talk about how we're going to get the other base. If the whole segment is 10, this is 3, this is 3. So subtract 6 from that. The other base is going to be 4. So now it's just a matter of finding that in simplest radical form. You know I'm going to love the simplest radical form. We have 1/2 times 3√3 times 14. 1/2 of 14 is 7 times 3 is 21√3. And we're not going to have any units because they didn't give us any units to start with. Find the area of the trapezoid to the nearest tenth. Okay, so our area is 1/2 the height times the sum of the bases. Well, let's see what they've already given us. This 6 here, since it's perpendicular to both of the bases, is considered the height. We know one of the bases is 8, so we're going to have to do a little bit of work to find the other base. From this vertex up here, if I drop a perpendicular down, I know this is going to be 8. I know that that height is 6 because I have a rectangle in there. I need to find x. Since 38 isn't one of our common angles, we have to use trigonometry. So I need to find x, which is the adjacent side. I know the opposite side, so we're going to use the tangent of 38 is opposite over adjacent. If I multiply both sides by x, and then I divide by tangent of 36. I'm sorry, tangent of 38. Now find that in your calculator. I'm not going to pull up my calculator. That's just a matter of typing that in the calculator. That's 7.7. So therefore, the whole other base is 15.7. So the area of our whole trapezoid is 71.1. And again, I didn't give us units, so we can't find, we don't have to put in units squared. Next example. And this is an even that I took from the book that's very similar to some odds you're going to have. So an isosceles trapezoid with bases 12 and 16. So 16 is on the bottom, we'll put the 12 on top. Is described as a circle of radius 10. The center of the circle lies in the interior of the trapezoid. Find the area of the trapezoid. So I know I have bases of 12 and 16, and I know the radius. Coming up here, since that's a point of tangency, perpendicular is 10. Now you can draw the radius anywhere you want, but if you draw it up perpendicular and then down perpendicular, I found the height. So area is 1/2. The whole height is 20, or the diameter of that inscribed circle, times 12 plus 16. So our area is going to be 280 square units. I didn't give us units, so you don't have to put units in. So those are some examples to help you to find area of a trapezoid. There are your lesson questions for the day. Please make sure those are submitted on time.